This section is about the Euclidean algorithm and finding the greatest common divisor and then starting to look at what you can actually use this for. So I wanted to start with just the greatest common divisor. So we're going to find the GCD, greatest common divisor, of 210 and 252, just two numbers. The way I learned to actually do this in elementary school would be to find the factors, do a factor tree. And I know 210 is 10 times 21. 10 is 2 times 5. 21 is 3 times 7. And then I would do the same thing with 252. 252 is even, so I know that's 2 times 126, which is 2 times 63. 63 is 7 times 9, and 9 is 3 times 3. So I could write these out and say 210 equals, I'm going to write them in order, 2 times 3 times 5 times 7. And then 252, I have 2 times 2 times 3 times 3 times 7. And what we looked for were numbers that were in common. Factors, prime factors that were in common. So we had a 2. So I'd write down a 2. We had a 3. I'd write down a 3. And we have a 7. I could write a 7 down. So my greatest common divisor is the product of these three numbers. So I have 2 times 3 is 6. 6 times 7 is 42. So the greatest common divisor of 210 and 252 is 42. That's one method for finding the greatest common divisor. Sometimes finding the prime factorization isn't easy. So there is another method called the Euclidean algorithm, and it's on the first page of the text. But I wanted to actually go through what all those variables mean with a real example. So I picked two random numbers. And let's say that we are going to find the greatest common divisor of 1042 and 398. And I may be sorry I picked numbers that are that big, but we're just trying to find the greatest common divisor. This is one use, not the only use, but one use of the Euclidean algorithm. So the very first step in the book would be to write it out as A equals your first quotient. In the book they call it Q sub 1 times B plus your very first remainder. So A is our bigger number, B will be the smaller number, so I'm going to do 1042 divided by 398. That will give me a quotient and a remainder. So it would look like this with the numbers 1042. Now 398 goes into that twice, so 2 times 398 with a remainder of 246. Okay, the next step of the Euclidean algorithm says to take your two numbers here, your remainder plus what you're dividing by, and they become your next two numbers that you're going to look at to write this out. So we're going to write 398 in terms of 246. If you look over here, they take your B and your first remainder, and I'm going to say that B equals, we need a different quotient, so Q sub 2, times our first remainder, but now we need another remainder. So I'm going to say 398 equals, now 246 goes into 398 once, so 1 times 246, with a remainder of 152. And then we would do it again. It's just like we're starting at this point. So I'm going to look at these two numbers, and I'm going to say that my first remainder equals, I'm on to my third quotient, plus my third remainder. So I would say that 246 equals 1 times 152, and I have a remainder of 94. And then I would keep following the pattern down. What you want to do is get to the remainder of 0, and then that tells you when you found your GCD. So I'm just going to work this one out. So this is 152 and 94 are my next two numbers. So 152 equals 1 times 94 plus 58. These are my next two numbers. 94 equals 1 times 58 plus 36. Here are my next two numbers. 58 equals 1 times 36 plus 22, and I picked a long one. 36 and 22. So 36 equals 1 times 22 plus 14. And 22 equals 1 times 14 plus 8. Wow. So 14 equals 1 times 8 plus 6. We have to be ending this soon. 8 equals 1 times 6 plus 2. And then finally, 6 equals 3 times 2 plus 0. 0 on the remainder tells us to stop. And right there is our GCD. So our greatest common divisor, believe it or not, of 1042 and 398 is 2. So that would be a very long example. Another example of this, probably something much shorter, I hope, would be if we actually just wanted to find, let's go back to that first example, that 42, and see if we can get that this way. So we're going to do, again, the GCD of 210 and 252. And we should get 42. We did that as the first part of this. So I'm going to start with the bigger of the two numbers, 252. And 210 goes into 252 one time. So 1 times 210 plus 42 left over. Look at my next two numbers. 210 equals 5 times 42 plus 0 left over. So 42 is here with my remainder of 0, which says stop. And I've got my GCD of 42 again.